Hello and welcome back to the course on machine learning. Today we're talking about the random forest and the intuition behind it. And specifically we're going to be talking about the random forest applied to regression trees rather than classification trees this time. But the concept is very similar, and you'll find that this tutorial is very similar to the one for the random forest on classification trees. Alright, so random forest and ensemble learning. So random forest is a version of ensemble learning. You've got other versions such as gradient boosting, and ensemble learning is when you take multiple algorithms or the same algorithm multiple times and you put them together to make something much more powerful than the original. And let's see how this works. So you pick a random k data points from your training set. So now we're kind of going to leverage a lot what we talked about in the section on regression trees. So you remember there we had lots of data points, and then we built a regression tree, and or we built a decision tree and used that to forecast the value that would be assigned, or the y value for any new element that would be added to our data set as the average in the terminal leaves, basically. So here what we're doing is we're using the whole data set we had, and we're only picking k data points from that training set. Then we're going to build a decision tree associated to these k data points. Rather than building a decision tree based on everything in your dataset, you're just building a decision tree based on those data points that you select, so a subset of your dataset. Then you choose the number of trees that you want to build, and you repeat steps 1 and 2. So you just keep building and building and building these trees. So you're building a lot of regression decision trees. And then finally, you're going to use all of them to predict. So for a new data point, make each one of your entries predict the value of y for the data point in question, and assign the new data point the average across all of the predicted y values. So basically, instead of just getting one prediction, you're getting lots of predictions. By default, usually these algorithms are set to about 500 trees at least. So you're getting 500 predictions for the value of y, and then you're taking the average across those. And in that way, you're not just predicting based on one tree, but predicting based on a forest of trees. And that improves the accuracy of your prediction, because it is you're taking the average of many predictions, and therefore even if one is for instance, somehow one of the decision trees was built exactly perfectly because the way of those data points were selected, so just didn't turn out as a perfect tree or a great tree even. If you were using it by itself, you'd get a bad prediction. But because you're using the average, it is less likely, so you're going to get a more accurate prediction. And the second thing is that they're more stable. Algorithms like this, ensemble algorithms, are more stable because any changes in your data set could really impact one tree, but for them to really impact a forest of trees, it's much harder. So therefore, ensemble is much more powerful in that way. And what this reminds me of is the game that is often played at fairs or parties and things like that, where you have a jar, and inside this jar there's lots and lots of, for instance, jelly beans, or it could be marbles, or there could be like a huge net with balloons inside it. And we have one in the mall sometimes where there's lots of balloons inside a net in the ceiling, and you need to guess how many balloons there are, and whoever guesses will get like a car, can win a car. And so it's like a crazy prize for just guessing number of balloons. And although this is not an example of specifically a random forest, a regression random forest method, it's still an example of an ensemble type of method. So the best way, or one of the ways to beat that game when you need to guess a number of marbles in a jar, for instance, is not to actually go and guess, but it's actually to get a pen and a paper and stand next to the person that's holding this jar or that's conducting this event, and you just stand next to them, and then you wait for other people to come and guess. Every time somebody guesses, you just ask them, as soon as they're like guessed and they're walking away, you ask them, hey, because usually they write down their number and they put it inside a like an envelope or something, and then the winner is announced later on. So they don't know whether they guessed right or wrong. But regardless of that, they're walking away and you just ask them, hey, what number did you guess? And you just write down their number. And then the next person guesses and you write their number down and you write their number. And you keep writing the numbers down. And you just keep doing that until you have like a substantial number of entries, maybe 100, or maybe if it's a very popular contest and people are guessing like crazy, like trying to attempting the guessing, then you might even get like couple of hundred, or even if you're very determined, you might get 1,000 of entries over a couple of days. And then what you do is you just average them out. Or if you don't want, maybe you take the median. If you don't want outliers, like people just guessing random numbers like 1 or 5 million, so you don't want them to affect, or you just take the outliers out and then you average out. Anyway, you either average it out or you take the median, and statistically speaking, you have a much higher likelihood of being closer to the truth if you take the average of people, because people are natural beings and their kind of visual perception will be most likely normally distributed. And therefore, once you hit the middle of that normal distribution, you are more likely to be on the money than any one of them. And that's a pretty cool concept. That's an example of an ensemble method where you're taking, instead of just performing that guess by yourself or taking the guess of one individual person, you're averaging out across multiple guesses, and you're more likely to be the closest one to the truth. And if the prize is given not just to the person that guesses spot on, but to the person that guesses closest to the truth, then you've got yourself a very powerful advantage using data science. So if you have the patience and determination, then try it out next time you see one of these games and see how you go. Would love to hear back from you, because I never have the patience to stand there and just count. But it is a statistical approach to a challenge like that. So hopefully you enjoyed today's tutorial. I look forward to seeing you next time. Until then, enjoy machine learning.